Well, welcome to MV Tutors. My name is Figa Manana, and today we are doing the topic of electrostatics. Now, I like to start my sessions with a vision. What's a vision? You say, well, it's just basically a previous past paper question. As you can see here, this is what we're trying to answer at the end of this session. This is what I'll be trying to teach you the principles that you need in order to answer such questions. And indeed, at the end, we will answer this. But, first we gotta learn the principles and then we got to apply them. Well, if this is what you're looking for, then stick around. At the end of this session, hopefully, you'll be able to do this yourself. Well, let's get right into it. Okay, let's start here. Well, the topic of electrostatics really we cannot talk about it without talking about this law called Coulomb's law, right? Let's define this law. Now, in order to define this law, they like asking the question, define this law. What you're really defining, when you look at it, you're just defining the equation of it. So you need to know the equation, this equation, Coulomb's law equation. And then basically what you're describing then is just this in basic terms. So let's put this in words, okay? So we're going to say Coulomb's law says the magnitude, okay, the magnitude of what? Well, the magnitude of the electrostatic force of the electrostatic force now that it's this force, right? Okay, what about it? What about it? The magnitude of electrostatic force, the force exerted by one point, okay, by 1 point charge. Okay, so the point charge Q1, let's go to the Q1, okay, on another, okay, the other one is Q2, right? This Q2, okay, is directly proportional to the product product means the multiplication, the product of what? Okay, the product of the magnitudes, the product of the magnitudes of the charges, and okay, the same force, okay, the same force is, okay, now let's talk about this r squared. What is that? That's distance, and it is inversely proportional. Inversely proportional, okay, to the square of the distance. So r is just distance between them. Okay, so all we just did was just describe the formula. This formula, you'll get it in your formula sheet. Just be aware that it is actually Coulomb's law. Now, let's take it a little bit deeper now. We've spoken about Coulomb's law. Now let's speak about the actual charges. All right, let's speak about the actual charges. Now the first charge is a positive one. Okay, now there's something you have to know about a positive charge with reference to its electric field. That a positive charge has an electric field that is actually, this you have to know, points away. So electric field, okay, the electric field, what about it? Points away. Just like that. That's for a positive charge. But now for a negative one, look at this. It's like that. Okay, it goes in, just like that, goes inwards. See that? So the electric field here of a negative charge, actually, what does it do? It points inwards. Okay, just like that. So now, if for example you have two positive charges, what happens? Okay, so let's say you have two positive charges. What's gonna happen? They're gonna basically repel each other. So what can we say? Or even if you have two negative charges, they will just repel each other. So we can say like charges repelled. Okay, but now if you have let's skip to the positive one. Let's say you have a positive one, okay, and a negative one. Okay, so what's gonna happen here? Okay, they actually attract each other. Okay, like that, just like that. So then we can conclude then that unlike charges or opposite charges attract. Okay, remember that. All right, let's now speak about actually the electric fields. Okay, but before we do that, I want us to conclude with what we just spoke about. Okay, so here is a disclaimer. When using Coulomb's law, okay, we do not consider the sign because we're just calculating the magnitude of the force. But the signs, we only consider them to tell us whether the force is a force of attraction or a force of repulsion. Okay, so let me just put that in words just in case you didn't understand what I just said. I said when using Coulomb's law, okay, we do not consider the signs. We do not consider the signs, whether it's a positive or a negative one. We don't consider it. But we consider the signs, let me say, to give us direction as direction, whether the force, the direction of the force, whether it's a force of attraction or repulsion. Okay, that's it. Just always remember that. Okay, now let's speak a little bit then another principle that we need to understand is that when we're talking about electric fields, okay, so here now sometimes they give you a point load, or let's say maybe you have a positive charge, and now to calculate, and we know it goes away, right? Now to calculate the electric field, remember these arrows are for electric fields. To calculate the electric fields, okay, so the formula for electric field, or maybe let me just start here. Let me say, because it depends what you're given. When given a force, okay, if you have the force, the formula for the electric field is equals to force divided by the charge, okay, the charge magnitude. All right, but now when given a distance, okay, when given a distance, the electric field then is K, which is a constant, and then the charge divided by the distance squared, okay, where K, the constant K, is equals to 9 times 10 to the power 9. Okay, so depending on what you've been given, that's what you actually use. Okay, now while we're on that topic of electric charge, there's something else that I want you to be aware of. Okay, now it is actually the net force between charges. Okay, so let's say you're given 3 charges. You're given a positive one, and on its left is another positive one, and then on its right, okay, I want to use different colors. Okay, let's go for blue for positive, and then there's another positive on its left, but on its right we have a negative one. Okay, so now electric field, what will the electric field look like here? Let's consider electric field on the middle one. So what happens? These 2 positive ones will repel, but these 2 negative ones will attract. So this one, let's say it repels by a big magnitude like that. Okay, so obviously if it's repelling, then it's gonna go that way as well. And then between these two, now we have a positive and a negative, they attract. So they attract like that. Now for the net force will be like going that way, because the magnitude this side is bigger than the force of attraction. The force of repulsion is bigger than the force of attraction. Okay, now let's do a different configuration. Let's say now I have a negative charge here, and then I have the positive charge right there, and then I have another negative charge right here. Okay, so let's do this. Now let us say, look at these two charges here. Between these two charges, they will attract like that. Okay, and then between these two again, they will attract like that. But now the net force will actually be the resultant, which is there. And for this one, to calculate the net force, then we need to use Pythagoras. Remember Pythagoras? Okay, so Pythagoras is r squared is equals to x squared plus y squared. That's Pythagoras, just to remind you. So it depends the configuration you have been given, and that's the configuration you use to solve the net force, and also the magnitude of the force between charges, and considering their electric fields, then you will conclude like that. Well, I guess that's all the charges. I mean, that's all the principles that we need to learn right now for this section. But now let us try to use these principles that we've learned to answer the exam question. Okay, so here we go. It says two small spheres x and y carrying charges of 6 microcoulombs and 8 microcoulombs respectively, I see them, are placed 0.2 meters apart in air. State Coulomb's law in words. Well, you can we've already spoken about it at the beginning. Okay, here it is right here, just in case you missed it. The magnitude of the electrostatic force exerted by one point charge on another is directly proportional to the product of the magnitudes of the charges and is inversely proportional to the square of the distance between them. So we just described this formula. So you see the force directly proportional to these charges and inversely proportional to this r squared, which is the distance squared. Okay, so that's all that you had to do right there. And then it says calculate the magnitude of the electrostatic of force experienced by charged sphere x. Okay, so what force is experienced by that? We know the formula already, so we can go ahead and answer that. Formula for force, because we are really calculating the force, so we know it's the electrostatic force. We know it already. That's the formula is Q1 Coulomb's law. Okay, so what is K? We already defined it, that it is actually 9 times 10 to the power 9. Okay, and then what's Q1? Q1 is 6 times 10 to the power minus 6. And then Q2 is 8 times 10 to the power minus 6. And then divided by, what's the distance between them? 0.2. So we put 0.2 and then square it. Okay, let's bring out the calculator. There we go. So we put the fraction sign, and then we'll go 9 times 10 to the power 9, and then go to the side and then say 6 times 10 to the power -6, and then go to the side again, and then put 8 times 10 to the power, I think I made a mistake there. I don't know how it will affect my answer, but I forgot to put a multiplication sign there. Maybe the calculator will know. Anyway, bottom one is 0.2 squared. Let's see. I knew it. I had forgotten to put multiplication sign. So anyway, let's do that right now. All that I'm missing is a multiplication sign down there, and also multiplication sign there. Cool, we are now cool. So the answer is 10.8. It's equals to 10.8. And what's the SI unit for force? It is newtons. Cool. All right, so that's our answer. Then it says a third sphere Z, so they just put a third one there, of unknown negative charge is now placed at a distance 0.3 meters below sphere Y in such a way that the line joining the charged sphere X and Y is perpendicular to the line joining the charged sphere Y and Z, as shown in the diagram below. Okay, I see that. So 7.3, draw a vector diagram showing the direction of the electrostatic force and the net force experienced by charged sphere Y due to the presence of charged sphere X and Z respectively. Okay, so it's not too bad. So I have working to do the way that I do this. So we've got sphere X here, right? And then we've got Y over there, right? And then we've got Z over there, right? Now what's happening? This one is positive and that one's positive, so there's a force of repulsion, so they repel each other there, like that, right? So they repel each other. And then there's this they told us Z is actually negative, which means they attract each other, like that, right? There's a force of attraction now. And then the one that we actually have to draw, the one that they want us to draw rather, is this one over here. So we need to isolate that, and in isolating that we're gonna get that it's going to be like this. It's gonna be like this. Our final answer is going to be like going that way, and then also going down. So what's this one? This is the force, okay, of X on Y, and then this one is the force of Z on Y, and then over here then we will have the resultant force, which is F net, just like that. Okay, so this is the one they wanted us to draw. Cool. All right, let's go to the next question then. They say the magnitude of the net electrostatic force experienced by a charged sphere Y is 15.2. Calculate the charge on sphere Z. The net electrostatic force. So they've given us the net. Okay, now remember this, to get F net, that's really Pythagoras. Okay, so 7.4. We know Pythagoras, we know F net due to Pythagoras squared is equals to the force of X on Y plus, and then it's squared, plus the force of z on y squared. Now they are telling us that the net one is actually 15.20, and we're gonna square it due to Pythagoras. And the force of xy, we solved the force of xy over up there, 10.8. So we're gonna have 10.8 over there, and it should be squared plus the f, okay, z on y. So we have to solve this force. Fortunately, we can do that easily by saying 15.2 squared, okay, minus 10.8 squared, and all of this should be under a square root. Okay, so let's bring our calculator back. Let's put it this side. Okay, so we're gonna say square root sign. Let's get rid of this square root, and then 15.2 squared minus 10.8 squared, and then we get that 10 points, let me just say 10.7. You get 10.7 newtons. But hang on a sec, what did they want? Calculate the charge of sphere Z. So we are not done. Okay, so from there then we will come over here. Okay, we'll come over here. We've got the force. Remember, Coulomb's law says the force really is equals to the constant and the charge. So charge 1 will actually okay, let's just put both of them, divided by the distance squared. Okay, so I want us to look at this carefully. Charge 1 is actually charge y. Okay, so here if we are having the force of zy, that means charge 1 can either be z or y, doesn't matter. Let me just say it's y, so that charge 2 is just z. Cool. So what do we have? We have that this is 10.7 is equals to the constant there is actually 9 times 10 to the power 9 times charge y, we have it there, it's 8 times 10 to the power minus 6, and then times qz, which is the charge that we're looking for, and the distance between y and z we've been given there, 0.3, and it should be squared. Now we just have to do some mathematical gymnastics, okay, to calculate the final answer. Okay, so what am I gonna do? I'll just say qz is then equals to that 10.7 times 0.3 squared divided by this whole thing, 9 times 10 to the power 9 times 8 times 10 to the power minus 6. Gotta put that in a calculator. Okay, so that was my answer there, times 0.3 squared divided, that's just gonna be complicated. Let me just do it this way. 10.7 times 0.3 squared, and then I'll come downstairs, I'll say 9 times 10 to the power 9, and then go to the side, times, don't forget to put this times because last time I forgot, yeah, and I got an error. 10 to the power negative 6. Okay, what do we get now? 1.3. Let me just take two decimals. 1.34 times 10 to the power 5 negative 5. It was 1.34 times 10 to the power negative 5. And what are the units for charge? It's coulombs. That is our final answer. What is that? That's our final answer. Okay, well, I sure hope you understood everything that we just did together. But in the event that you didn't and you need a tutor, I would love to tutor you. Contact me on my website www.mvtutors.co.za, or alternatively you can WhatsApp me on 076-312-1107. But before you do contact me, please speak to your parent or your guardian before you contact me, because remember, at the end of the day, they are the ones who will be paying for my tutoring service, so they need to be involved from the beginning. Okay, well, other than that, just like and subscribe our channel so that more students could have access to this content. And that's it for me. Thank you so much for listening, and I appreciate you.